Okay, so we're back to organic compounds and naming organic compounds. So you should be getting practice on naming some of them, and so we can go into some other things that go on into these compounds. So when we have a compound that is forming a circle, so we have these things called cyclo. Oh, let me see my pen right. Cyclo. Again, I'm wearing a blue pen because I have blues in my dress. See? So, yes, I'm color coordinating for all of you guys out there. So we have cyclo compounds. And what we do is we call them cyclo because they form a ring inside of there. And like if we have a compound like this, which is a 6-carbon ring, if we do it all single bonds, we do it like this. Okay, so this is supposed to be represented a circle. So this is cyclohexane. So because it's all single bonds, this is supposed to be what's called the chair configuration. You can also have it do this, where the bonds show it making like a seat kind of thing, but this chair configuration where there's a back and then there's this forward part in here. That's the most common way of drawing it. To me, it looks like the Budweiser symbol. So every time I see the Budweiser symbol, if you guys really look at it, maybe I'll pull it up. It really does. I'm not really good at drawing. Not one of my skills. It looks like the Budweiser sign. So, ooh, hold on. I will show you guys what I'm talking about. You guys can be as crazy as I am. So, yeah, look at this. So it goes down, it goes across, and it goes back up. See? It looks like cyclohexane. They just drew it the opposite direction. I usually draw it up on this side, but it looks like this. So when I see this, I think cyclohexane. Yes, I am that insane. Okay, so cyclohexane is where we have all single bonds inside of it and everything like that. And it's all single bonds. So we all have single bonds. Now if we did this, and we drew this over here, and I drew this over here, what would that be? Well, that would be 1,4-dimethyl cyclohexane. Because now I have a methyl group on the first and the fourth. 1, 2, 3, 4, 5, 6 carbon. So I have a methyl group on the first carbon and on the fourth carbon. There's 2 methyl groups, so it's dimethyl cyclohexane. Now, this is not the same. This is the table configuration. This is not the same as benzene. Okay? Because benzene, when we draw it, we usually draw it this way. And we draw it's single bond, double bond, single bond, double bond, single bond, double bond. Or we draw it this way, the circle, because these double bonds doesn't matter where you draw them. There's actually kind of a circle of electrons that flow around the outside, so we do this. These two things are not the same, okay? And this is really important. If you don't put the circle in the middle, then you're actually saying cyclohexane, or you have to draw the single bond, double bond. So keep this in mind, because this is something students forget about, and so this is a different compound. So going back to the cyclo compounds, if you have things like this, there's 3 carbons, so this would be cyclopropane. If you have a square, that's cyclobutane. If you have a penta, so cyclopentane. I think you get the gist, okay? So this is kind of an important part of this, is this idea that cyclo is a circle. If they're double bond, you use the word cyclo. If they are this with hexane, but it's single bond, double bond, it's benzene, okay? Just so you know that. Okay, something else that I wanted to go into so that you guys will know some of these other things to name. Let's move this up, is isopropyl. So where have you guys heard isopropyl before? Probably isopropyl alcohol. Okay, so now you guys are going alcohol. Ooh, it's got an OH group into it. Propyl means 3. Okay, but what's this iso? What's iso mean? Well, what an isopropyl group looks like is this. So when we draw the configuration here, or we could draw it like, so this is isopropyl. Okay. You could also draw it like this, CH3, CH3. So this has got 1, 2, 3, 4 bonds. And now this connects onto whatever compound you want. Okay? So if it forms this little V shape, and then you've got this little functional group here that is connecting on to anything, this is an isopropyl group. Okay? So this is isopropyl, so if we go this isopropyl alcohol, we add an OH onto there, now it's isopropyl alcohol. Okay? So now that becomes isopropyl. This is isopropyl as the group. Okay? So we have propyl. So if we have propyl, it would be CH3, CH2, CH2, and then it would connect on to it. Okay, this is isopropyl. You can also get what's called, this is also referred to, you could also call it 1-ethyl-methyl. This sounds really bad, because you can say, okay, there's an ethyl group here, and there's a methyl group onto it, and it's on the first carbon, so this could be 1-ethyl-methyl. Don't use that, use isopropyl, it just sounds better. Now there is butyl. So butyl also has these kind of weird things that are going on. So we have butyl. So how many carbons is butyl? So it's a 4-carbon chain that comes off of it. You can have something called sec-butyl. And sec-butyl is where you have CH3, CH2, CH3, and then this gets connected onto it because it's got 4 carbons, 1, 2, 3, 4, but the little chain comes off not at the end with a butyl, which would be 1, like that, So what we're trying to do here is say, oh, there's a group over here, so that's sec-butyl. Then there's isobutyl, and you might hear isobutyl. So isobutyl is CH3, CH, CH3, CH2. And this could also be referred to as 2-methylpropyl, because there's the methyl group, there's a propyl group, so this could be also 2-methylpropyl. But we also refer to it as isobutyl. And then there's tert-butyl. Tert-butyl. And that one is CH3H, CH3, CH3, and this comes off, and this is tert-butyl. We're going to get into MTBE here soon, and I will draw that very shortly, but I want you to think about this. MTBE is methyl tert-butyl ether. So think about what an ether group looks like. You now know what a tert-butyl looks like, and then there's a methyl group that's also connected onto it. Why are we going to talk about MTBE? MTBE was used probably about late 90s. It was really a big idea because of the ether group that comes into here. The ether groups have oxygen into it. So what it was is this is a very cheap compound to make. So it's very easy to make, and because it's got that oxygen in it, and we add it to gasoline, it makes gasoline burn cleaner. And it's cheaper to make than ethanol, and so it was upping the amount of burning of your fuel because you're adding oxygen into your fuel so it burns cleaner. So this was a cheaper way of going than using ethanol. Well, what ended up happening is methyl tert-butyl ether got into our groundwater supply, and say inside of an entire water tower, there's a water tower behind me somewhere, I poured 1 cup of this compound into it, the entire water would taste like turpentine. And so what happened was even though it's not a cancer-causing agent, it really has a strong taste. So from an aesthetic point of view, your water tastes like turpentine, you'll never drink it, and it's really, really low concentrations of it. So MTBE became a big contaminant because it's actually really water soluble, and we'll get in more into solubility here probably next week, getting into some of the information about it. But when we mix it to gasoline, remember when I talked about gasoline? Gasoline gets spilled, right? And the first compound that comes off is benzene. And then I'll get into what toluene, ethylbenzene, and xylenes are like. Those come off really quickly off your gas. What stays behind is the isooctane, which we talked about last time. Well, what happens is when you add this compound, this MTBE, this methyl tert butyl ether, this is our tert butyl, when we add this compound to gasoline, this is so water soluble, this comes off even before the benzene and moves right with the water. It has no sorption. We'll talk about retardation factors and sorption and everything like that, predicting it. This has absolutely none. This moves right with the water. It's kind of like alcohol because it's got that oxygen into it. It moves really quickly through the aquifers, and so it was coming out way before gasoline was spilled, and it was coming out, and it was getting into a lot of aquifers. We've cleaned up a lot of those. If you talk to Megan, one of her jobs when she was working for a consulting firm was cleaning up a lot of MTBE sites. Just so you know, Illinois, we never went to using MTBE because we were under the idea that we should be using ethanol since, we have corn and soybeans and corn, and, that's the only thing we grow here. And so the state of Illinois did not implement using MTBE, so we have very, very few. The only spots we had were a few spots in Chicago where the gasoline was going other places and they did a small spill. So we really don't have a problem with MTBE in the state of Illinois. But I just wanted to bring this up. I'll go into drawing it later on, so remember this whole story later on.